Hello and welcome to Dinis Guarda, citiesabc Open Business Council YouTube podcast series. We are a platform that's been profiling some of the leading global thought leaders and people driving the world, our cities, and our society. And we are particularly interested to look how we can actually make bridge between creating a better society that we've been actually discussing around the concept of Society 5.0 and a lot of other areas like the fourth industrial revolution, and as well to understand the people behind the technology, behind the infrastructure, behind the organizations that are shifting our world and taking us forward. Our series has been profiling leading personalities, and we've been going for the last 1 year with over 150 people. And actually, every person is a special ecosystem, a special universe. I would say that every human is the humanity in himself. But here we are as well today, focusing on in one leading scientist and technologist that has been shifting the way we look at technology, especially in the areas of blockchain and a lot of other areas in terms of public ledgers. And I welcome to our series Professor Leemon Baird, that is the co-founder and CTO of Swirls Inc. And the organization behind the Hedera Hashgraph, and as well a professor at multiple prestigious universities and senior scientist in several labs. So Leemon Baird has a quite substantial experience that has been going through startup and big corporations, and as well as a professor of computer science at the US Air Force Academy, and as a senior scientist in several labs. He was the co-founder of several startups, including two identity-related organizations, and both of which were acquired afterwards. And Professor Leemon as well received his PhD in computer science from the University of Carnegie Mellon University, and has multiple patents and publications in peer-reviewed journals and conferences, specifically in computer security, machine learning, and mathematics. So a huge background. And about Hedera, I think it's particularly important. It's one of the kind of powerful public ledgers that is quite unique. And I've been actually studying it myself for a long time. So Hedera is a decentralized enterprise-grade public network on which anyone can build secure, fair applications with finality and in few seconds. The platform is owned and governed by a council of world-leading organizations, including Avery Dennison, Boeing, Dentons, Deutsche Telekom, DLA Piper, and a lot of others. And it's been, especially the name Hedera Hashgraph, which is probably well known better, is a platform that presents itself as a faster and more secure alternative to blockchain. So it's partly public ledger, but it's a different parts, and we're going to touch that during the interview. So I want to touch this because I think it's particularly interesting, and there's a lot of variations on this. So Professor Leemon, it's a pleasure to have you here, and I'm quite excited to host you on this series.
Well, thank you for having me here. It's great to be here. I appreciate it.
So I want to start with your scientific education and your background, because you have quite a powerful background that touches a lot of things, from the scientific part and the academic, and as well to the entrepreneurial and the corporate level. So if you could tell us a bit about your background to start.
Oh, sure. So my PhD is from Carnegie Mellon University in computer science. I was doing machine learning things, reinforcement learning with neural networks, some of the stuff that we see now with AlphaZero and so on, just doing amazing things. I always did that back in the 90s when I got my PhD there. I was a professor of computer science, and I've been a visiting professor at various places, and I'm on PhD committees in various places. And then about 20 years ago, in addition, starting companies. So I've been an entrepreneur. So started a few companies that were acquired, and then I am the co-founder of Hedera Hashgraph. And that's what we're talking about right now is that it started really back in 2012 when I was just seeing, is there a way that you could have computers come to agreement with a very high level of security, ABFT, the highest level, but also be really fast. And I kept playing with it just as a fun math problem. And it was something I was able to play with and convince myself, yeah, it really isn't possible. You could have speed or security, but you couldn't have both. And so I'd put it aside. And then after a while, it would just kind of gnaw at me, and I'd come back to it and play with it. And eventually I realized, there's a really simple trick. If every message has 2 hashes in it, They all tied together into a history, and then you can do the voting virtually. You don't even talk to each other. And it's super fast and ABFT. So that's kind of the history of what I've done. I've done a lot of research in other areas too. So I talked about machine learning, but I've done Sator automata and math stuff and jam-resistant communication, all sorts of interesting things. I really like all of computer science, especially the parts that have an extra math component. I really like the math parts of it. And then I like starting companies. I've been doing that for 20 years.
Oh, quite impressive. So I think in terms of, well, I'm as well a bit of an academic and a bit of well, a lot of entrepreneurial. So one of the things I would like to touch before we go to Hedera Hashgraph, which I have a lot of questions, but so in terms of your background that took you to build Hedera Hashgraph, so can you tell us a bit of, from all this experience, how did you come up to build, and how did you build Hedera Hashgraph and why, and a bit more about what is the company?
Sure. So I just play with math problems because they're fun. In 2012, I had this problem of can you get consensus fast and secure at the same time? Just playing with it because it's a fun math problem. I have some that I've been playing with for decades and I'll probably never solve them, but sometimes I solve them. And then in 2015, I realized the solution to that. And Mance Harmon is a friend who has co-founded a number of companies with me. And he and I said, you know what, this Hashgraph thing would actually be very good as a distributed ledger technology. And so we started a company that swirls to do private ledgers to prove out the technology. We got traction there. And then we said, now we're ready. In 2016, we said, we're ready. Let's do a public ledger. And that's what Hedera Hashgraph is. And so we started it in 2017, announced it to the world in 2018, and launched the network in the summer of 2018, minted the coins. It's not inflationary. There's a fixed number of coins minted in 2018. Then in 2019, we opened it up for the whole world to use. In the last year and a half, we've been using it, and we've actually done more transactions than any other ledger in that year and a half. So, in a year and a half, we've done more than Ethereum has ever done. It's been fun. It's been a wild ride, and huge increase in the number of people using us, transactions per second, a lot of interest in it.
So let's go precisely. You mentioned Ethereum. So of course you guys have a fantastic technology powerhouse, but of course you don't have the credit that Ethereum or even other blockchain has, like EOS or Cardano. So can you tell us, although you're not a conventional, so you define yourself in a slightly different way. So I would like to go through the differences, because I think this is very important for people listening to us, and my audience is a lot of blockchain geeks, but I would like to hear a bit about that DNA that is unique from Hedera Hashgraph.
Sure. So Hedera is built on Hashgraph. So what we do is what every ledger does. Transactions are put into order. They are given timestamps. I guess not every ledger does the timestamps, but they're given timestamps. Most ledgers do that. We put them in order, and all of the computers in the network are agreeing on it. So that's traditional, and then we interpret those transactions. So you can move cryptocurrency around. You can mint tokens and move tokens around. You can run smart contracts. You can save files. We have that. And then you can also, if you want, create other networks, basically like private networks. You can do it on Hyperledger Fabric. You can do it on E3 Corda, whatever you want to do, and then use us as the consensus engine. Use the public ledger with all of those trusted nodes from the public ledger doing the transaction ordering and timestamping and so on for essentially a private ledger. So it's like an L2 system, although it's slightly different from some L2 systems. It tends to be the opposite, where the information is stored off of the ledger, but all the consensus is happening on the ledger. So we have that too. So we offer a number of different abilities, including this consensus service. The reason we're able to do it is because it's just incredibly fast. Right now, on the public ledger that's running right now, we have slowed it down to only 10,000 transactions per second. And we will increase that to a large multiple in the future. But right now, we've just slowed it down to a mere 10,000 per second, which is pretty fast. Other ledgers tend to be a lot slower than that. And the reason is because of the underlying math of the Hashgraph itself. The Hashgraph itself works in a crazy way. So I can go through it just briefly if you're interested, but it has a
I'm interested.
Okay. So here's the idea. We want to put things in order. So you give your transaction to one of our nodes, that node spreads it to all the other nodes. What's the fastest, simplest way to spread something? You do a gossip protocol, which is just brain dead simple. Every computer just says, okay, I'm going to pick another computer at random and give it the transaction. Now you have 2 computers. Then they both just pick someone at random and give them the transaction. Now you have 4 computers, and it just blows up exponentially, 8, 16, 32. Every ledger uses gossip to get information out because it is incredibly fast and super resilient. If an attacker shuts down one of the computers, we don't care. Gossip just spreads around it. It doesn't really hurt. So it is incredibly resilient and incredibly fast, and that's just to get the information out. The problem, of course, in most ledgers is in all ledgers, you have to figure out, well, now what order do we put them in? Because if we spread out these transactions with gossip, every computer gets them in a different order. Each node will have seen the transaction in a different order. We have to all agree. And we have to assume that some of the computers are malicious. We have to assume that, maybe almost a third of the computers are malicious and they will lie. They will collude with each other. They will maybe just turn themselves off if that's what would do the most damage. They do whatever hurts us. And we even have to assume that the internet is malicious. Maybe they can build firewalls around us. Maybe they're in a country. Maybe some of us are in a country that has a firewall around it. Maybe someone can do a DDoS attack, distributed denial of service attack, and shut down one of the computers. So how do we come to consensus even when there are attackers, malicious computers, malicious firewalls, DDoS attacks, all of those, and have a math proof that it's secure? So people have talked about lots of ways. You can do proof of work and spend lots of electricity, more than whole countries, but we're 5 million times more energy efficient than that. Or you could do some kind of a leader-based system or take turns being a leader. You don't have fairness, though, if you do that. One computer has the ability to influence the order more than all the other computers. What you want is for all the computers to have an equal vote on the order. So if you have a leader-based system, if you take turns being a leader, you don't have the fairness. And all of these systems take some time. What we realized, though, is that first stage when we were just spreading out the transaction, if your message has a couple of hashes attached to it, just 2 hashes attached to it, just cryptographic hashes, all you're doing is you're saying, okay, here's my message to you, but let me tell you the name of the last message I created and the last message that I received from somebody. That's it. When I give you a message, I just tell you, here's the hash of the last one that I created and the last one that I received from someone else. That's all that we're adding to that initial gossip, that initial spreading out the transaction, just 2 hashes. And what happens is that by taking the messages you've received and looking at those 2 hashes, they're sort of connectors. It's like Lego. They connect to earlier messages and you can build them together into a graph. You have a total picture of how everyone has talked to each other throughout all of history. So one computer sitting there gets the transaction, sure, but it also basically for free knows the complete history of how that transaction went through the network and when it reached each node and in what order it reached each node. And says, oh, I see it went over there and went to those nodes, and then it went over here and went to these nodes in parallel. It knows the time that it reached every single node, because when I send you a message, I have a timestamp on it of when I sent it to you. All of those things are visible, which means that the entire problem of trying to come to consensus with ultimate security, you do with 0 additional communication. No one sends anyone any messages for that. It's all built into that initial message. Those 2 hashes cover it. It gives you everything you need to know to get consensus. And so you have this guaranteed mathematical consensus, asynchronous BFT, which means asynchronous means we make no assumptions about the internet. Attackers can attack it and it's okay. And BFT means as long as less than a third of us are malicious, it is okay. We are guaranteed that we will come to consensus. That's liveness. We are guaranteed that we will all come to the same consensus. That's safety. We are guaranteed that once you come to consensus, you never change your mind, and you know that you have come to consensus and will never change your mind. That's finality. And we do it with 0 communication, which means, well, you can't be faster than that. You can't send less than 0 messages. So it's like at the mathematical limit of how fast you could reach consensus. You have to do the initial spreading out of the transaction, use gossip, that's the fastest way possible. And then at that point, you're done. And so we've shown hundreds of thousands in the lab where we're not actually processing them. The consensus is trivially easy and fast. We are doing 10,000 right now where we process them. And by process them, we even digitally create a Merkle tree and sign them to prove to you that these transactions are correct. Even all of that is happening at 10,000 a second, and we know we can go much faster than that. It's incredibly fast, and you have finality. Guaranteed, any given transaction, we're eventually going to know for sure, and we reach finality in just a few seconds. And so it just comes out of the math. The math problem I originally worked on just because it's a fun math problem. I'd love to talk about that. It's just fun. In fact, I have. I talked to math guys at Cambridge. Oxford. Whatever. I talked to the university. It was Oxford, I think. Talked to the math guys. That was a lot of fun. Anyway, it's been fun stuff. But what we end up with is a very fast and secure ledger, which is really half of it. You need good governance too, but half of it is to have a fast and secure ledger, and we have that.
Oh, that's impressive. And I know that there's a lot of, I want to touch one thing before I go to my next question. So can you make a difference? Because I know that, especially for the people that are less technical, a bit of differentiation between the public ledger part of Hedera Hashgraph and the normal blockchain. So I think it's an important question for the context of the way you set up Hashgraph in comparison to Ethereum or Cardano or EOS, which has different particularities. And you touched that, but if you could just answer on that part.
Sure. So in a traditional blockchain, you have a chain of blocks. That's why you call it blockchain. What we have is a directed acyclic graph, a DAG. So the data structure inside the system is different. The traditional chain of blocks, say in a proof of work system, you actually build little chains coming off of it that eventually get pruned off. They become stale and they get ignored. Whereas with us, it's nothing's ever thrown away. And the reason is it's as if everyone is not taking turns to build the blockchain. So in a traditional blockchain, all the computers have to take turns into who puts the next block. Maybe you do proof of work, and whoever solves a hard math problem using lots of electricity gets to put the next block. Maybe you take turns. Maybe you have a leader who puts all the blocks on, and then when they crash, you go to a new leader, and you have to go through the time of finding a new leader. And maybe a DDoS attack shuts down the new leader, and you have to go to a new leader, and you can play follow the leader. But somehow everyone has to take turns, which slows you down. With us, you don't. Every computer is adding multiple blocks per second to the blockchain in parallel at the same time. Because we have this thing where we get consensus for free, they just all know what order they need to go in. And so each computer is just sending everybody else, it's the equivalent of blocks all the time, not taking turns at all. At the exact same moment, everyone's creating them, and there's no stale branches that need to be chopped off. All of them are valid. Every computer is creating multiple blocks per second, and they're all valid. That's a big difference. And then to get the even more speed, we do the consensus and the mirror nodes are two separate nodes. So we have the consensus nodes that keep track of the current state. And if you send cryptocurrency from you to someone else, or send a token from you to somewhere else, or run a smart contract, they keep track of the result. So they know the current balances of all the tokens, all the accounts, how many tokens are in every account. The mainnet nodes know that. And then we have the mirror net nodes that have the entire history of everything that's ever happened. It's connected with cryptographic hashes, which would be as strong as a blockchain, but it's actually stronger because we also have digital signatures from all the computers on that. And so you can prove to a third party that it is absolutely the consensus of this network without having to give them the entire blockchain's history. You can just give them the equivalent of one block with the signatures, and a third party knows for sure that it is real and that it is correct, that it is the consensus of this community, and that it isn't a fork. If somebody tried to fork, they could create another ledger, but they would never be able to give you the digital signatures that they need to convince you that it's real. And so those are fundamental differences from what you see in other ledgers. And some people use the word blockchain to mean ledger, in which case we're a blockchain, but a different kind of blockchain, and one that works really well. Other people use blockchain to mean a chain of blocks, in which case you'd say we're a DAG, or we're something slightly different from a blockchain. But that's kind of the difference there.
No, thank you. I think you put it fantastically. So one of the, going back to my next question is that, so you have an impressive amount of global corporations and organizations using Hashgraph. And this is include a council that includes the likes of Boeing, Deutsche Telekom, DLA Pipers, WorldPay, Google, IBM, and so forth. So could you tell us a bit, how do you work with this network of companies and some case studies that you have that you would like to highlight?
Yes, we have this exploding set of people using us, including the council. And the council is worth understanding. The names you just said are not advisors. They aren't part of some consortium that's just talking about standards or something. They actually govern Hedera. In fact, they actually own Hedera. It's an interesting organization. The way it works is Hedera is split evenly into shares owned by the council members, and they control it. They own it, they control it, they make all the decisions, and they keep each other in check. And so the way it works is they are spread around the world in different countries, on different continents. We're on every continent except Antarctica. We'll work on that one. But we're all around the world. They're in different industries. Even the names you said are in very much different industries. You said DLA, which is a legal firm, and you said Boeing, which is aerospace, and you said IBM and Google, which is technology. I forgot what other names you said, but we have 20 names. We have a huge a lot of financial companies, a lot of telecom companies. We have, anyway, huge variety of different industries that they're in. And so they own us, they make all the decisions ultimately on what will be in the code base, what the pricing of the transactions will be, those sorts of things. They are term limited. Not only are they in different geographies and under different governments and in different countries and in different industries, they're even diversified in time. We are even decentralized in time. A member has a 3-year term. They can be voted by the other members to extend for another 3 years, and then they're out. They have to leave. And the reason is we don't want this to become ossified, just calcified. It just ends up becoming bureaucratic and bogging down. We want to decentralize and diversify even temporally, even in time. And so there are term limits, and they have to leave. They can come back again later if they're voted on by the council, and the council itself can vote them back in. But that's how it works. So the council even controls the council, or at least they will when it's all done. We're more than halfway there. We're going to have 39 total. We have 20 today, and will be other announcements coming soon. So we will very soon be hearing about more. I'm really excited about that. Anyway, so we have that. And brother, I didn't even talk about the diversity. We even have University College of London, UCL, one of the top 10 universities in the world. And we're looking at getting more universities and other people. So this is the council, and they are the governing council, and they govern. And we, honestly, this is more decentralized governance than you see anywhere else. Everywhere else, what you have is not transparent governance. That's a huge difference. Here, you know exactly who the governors are, and they are large corporations. It will be expensive to bribe one of those, more so than an individual. It would be fairly difficult. And they have a reputation that they care about because they've been around for a very long time. They're the equivalent of Fortune 500 around the world. We have very high standards. And so they've been around for a long time. They know what they're doing. They're hard to bribe, and they keep track of each other. And because of the nature of Hashgraph, a third of them could be compromised and hacked into, and it wouldn't matter. The network would be totally reliable, totally keep running. It would run just as fast. They can't slow down the network. They can't stop consensus. They can't double spend, any of those things. They're not all in one country, so you couldn't have a government nationalize them all and then take control and destroy it. It's very, very decentralized governance, and it's totally transparent. Their decisions are made with a council meeting that happens every other month, and those minutes are published. And everything we're doing is published. The code is all open, everybody can see it. Open review for the very core, and open source for everything else. Everything we're doing is open. The way that we add more features to the network is, of course, someone has to come up with the idea of the feature, and then it has to be programmed, and then we have to make the decision, when does this go into the code base? And the way we do it is the community comes up with the idea. We have a HIP, Hedera Improvement Process, and people do that. And then it is implemented. It can be implemented by us in-house, and it can be implemented by the community and donated. It's open source, either way. And then it has to be approved. It is approved by the council. This is what the council does. So this is what our council is. And we have seen network effects within the council, and then we've seen network effects with the use cases. And you asked about the use cases. The council itself is building applications. That's, actually every single one of them said, we want to join you because we have things we want to build on top of you. And we have some very exciting ones. DLA Piper is doing tokenization in some very exciting ways. We're seeing Google doing some cool things. We're seeing a lot of them. Avery Dennison is doing amazing things, and they're cooperating with Suku to do tokenization. And a lot of the council members are building on us, but cooperating with others. DLA is cooperating with others. And so you have other applications, dApps, distributed applications, cooperating with council members, working jointly on these projects. And so we're excited about that. And so we see this network effect of the council builds something and the outside world's building something and they're working together. We also see network effects in just the council recruiting itself. So, we have tech giants like IBM and Google, our council members, and that then led to others being attracted to the council. So like Shinhan Bank, the oldest bank in South Korea, became a member. And you have Standard Bank, which is the largest bank in Africa, became a member. And you have Nomura, one of the largest financial institutions in Japan. All of these are becoming members. And why are they so anxious to become members? Well, part of it is because of the pedigree of the current members. And so we're seeing this network effect, this snowball effect, where it keeps growing. It becomes easier and easier to get members, and they keep coming faster, and we're getting huge names because we have huge names. But we're not just seeing that. We're seeing the network effect among our users. And so we're seeing things like, you can use Hedera because of the incredible speed, and of course, incredible speed means incredibly low price, 1/100th of a cent for most of the transactions that are going through the network. 1/100th of a US penny. So a 10,000th of a US dollar, denominated in dollars, not in Hbars. So when we have volatility of our cryptocurrency, your company still has predictability of the price and the cost of using the network. That's important. So what we have is incredibly cheap transactions that are incredibly fast. They reach finality in seconds, which has encouraged people like AdStacks. AdStacks is sending lots of transactions per second through because they want to stamp out fraud in the advertising industry. You have people that want to advertise on websites. You have websites that want to show advertisements. AdStacks can connect them to each other so that these people can be advertising on these people and do it with everything recorded through Hedera at 10,000 per second, a 1/100th of a penny each. They can do it very, very fast and cheap. And then it's recorded forever. And so both of them know that both of them are saying the same thing. If a website could, if it was just doing this by itself, tell this advertiser, yes, I showed your ad, please pay me. And at the same time, tell this advertiser, I showed your ad. Even though it only showed one ad, it could tell them both, I showed yours, and lie to them. But because of AdStacks, that becomes impossible. You can't say two different things to two different people. It records it immutably, unchangeably, and guaranteed, unforgeably, and it's guaranteed that the whole world sees the same record. You can't have two different sets of books. So it completely eliminates an entire class of fraud. They're so excited about that. They're sending huge numbers of transactions through us. You have people like the Coupon Bureau now doing the same thing with coupons. They're the largest organization in the United States for coupons. When you go clip a coupon out of the newspaper and take it to the store and spend it, there's a very good chance it's flowing through the Coupon Bureau, regardless of the store you're using. And they are now using us to record in the same way I just described for AdStacks, for the same reason. You want to have this permanent, immutable record, and you want it to be showing up very fast. That's important because you want to make sure that if there's unique coupons you've given out with serial numbers on them, that you don't have somebody just spinning a Xerox of one of your coupons. And you wouldn't believe the standard in the world today for how coupons are managed. You get big bags, garbage bags full of paper coupons sent off to a third country where labor is cheap to manually have humans will go through and enter them all into a computer, and the store gets reimbursed months later. Can happen. With this thing, everything happens in seconds. So it's incredible. And that's what they're doing. And so you have a lot of people that come in because of these network effects. You see one person doing proof of action, and then another person wants to do proof of action. Or you see people that want to have immutable records of provenance of things. And so we have pharma companies. Let's see, one is doing supply chain pharma for all of the Kingdom of Bahrain. We have others doing pharma in other ways, and also provenance of other materials, foods and things. And so what you do with the provenance is that you prove that this drug I'm taking, the raw materials started here and they went through these labs and they went through these storage places, and you can track the history. Or if you're reading food that says organic on the label, how do you know it's organic? Well, you can trace exactly how it came. Or how can you know that it was ethically sourced and it wasn't slave labor or child labor that was sourcing this cobalt or these cocoa beans or whatever? How do you know that these diamonds aren't blood diamonds that came from some warlord that was doing evil things to get them? Well, you track the provenance and you put this immutably into us. And so there's a number of companies doing that. And I see a network effect where the more that do it, the more want to do it. And so we're seeing a huge number of transactions per second from that. We see use cases now in tokenization. I am extremely excited about the future of the world with tokens. We have people building tokenization systems. I told you about DLA Piper doing it, but we have others now too. Suku and others are doing this to be tokenizing information, assets, I mean. So you can take art and you can tokenize it. You can take real estate, you can tokenize it. You can take stocks, you can tokenize it. A galaxy is the coolest thing. The creator's galaxy. Spencer Dinwiddie is doing this with us. And I'll be talking with him at Consensus tomorrow. I am so honored to be sharing a stage with, well, one of the top basketball players. He's a starter for one of the top teams in the world, but also an entrepreneur that is really deep in the blockchain and the ledger world. He's been doing this for more than half a decade. He's been really into this for a long time and has some fantastic economic ideas. And he allows people to monetize themselves even, where you can even monetize and tokenize your time and bonds against your future contracts and earnings, and just amazing ideas for allowing creators to tokenize. And so we have this network effect of all these tokenization applications where he's doing it for creators, and DLA Piper is doing it with fine art and other expensive collectible things, all sorts of things. We have auctions. I'll talk about auctions in a second maybe, but just the use cases are endless, and that's why we're seeing an enormous number of transactions per second. I mean, tens of transactions every second, 50 or 100, or sometimes we see a couple hundred, but we're averaging 50 or 100 or something right now. Huge number of transactions every second flowing through the system because of all these use cases, because these are real transactions, not test transactions. These are real ones from real people.
So one of the things I would like to touch there, because I'm particularly interested on that. So you mentioned, tokenization. You mentioned, and I know that you have case studies around identity as well. So now we have this big explosion of NFTs. So are you doing any kind of solutions in this area? Because most of the biggest blockchain providers, of course, Ethereum is still leading most of this, but ultimately probably the NFT is the first big, I would say, mainstreamization of blockchain technology, because it's really taking mainstream to the masses, especially with, you mentioned art, music, film, but as well on collectives, sports, and a lot of different things. And there's a lot of things, for instance, right now, most of the biggest platforms are trying to do it. So actually almost all of them are trying to do this, especially I've been studying a couple of them. So in terms of what you've been doing, especially in the areas of tokenization, and you mentioned, of course, DLA Piper, but in terms of art and other things, are you doing this mostly from a platform perspective, from a transaction perspective? If you could give some specific examples, and if you are doing something in the area of NFTs or similar solutions.
Yes. So when I said DLA is doing tokens, it's NFTs. NFTs are incredibly exciting. I would love to talk about how I think it's going to change the world. It's It's taken off very, very fast this year. So what we did is that we have a number of services that we've rolled out to the world. The latest one we did, which was, I don't know, a few months ago, was our token service. And so we have fungible tokens, you can do non-fungible tokens, and it runs at the speed of the native layer. You don't have to use a smart contract. You can if you want, but smart contracts are slower. It runs, but you can do tokens at the native layer, so they're extra fast. And we have enormous traction on this. A lot of people are interested in doing fungible tokens, non-fungible tokens at the native layer speeds. In addition to that, you could, if you wanted to, do them in a smart contract, which is somewhat slower, but more flexible. Or you can also get the best of both worlds. And we have people working with us for that as well. Instead of using the token service, use the consensus service. The consensus service lets you run your own network or have a group of people running a network, either way, whose consensus is being done by Hedera. And then you can write a program that does anything you want. You can do NFTs or whatever else you want with infinite flexibility, write in any language you want, and it will run at the speed of the native layer. So it's all three that we're doing for NFTs. You can do a smart contract, which gives you infinite flexibility, Turing complete, but is slower. Or you can do it at the native layer, which is more limited, but runs right at the speed of the native layer. Or you can get the best of both worlds and use the consensus service and run at the speed of the native layer, but have the flexibility of a smart contract. So it's Turing complete, can do anything, but it runs at the speed of the native layer. And you can do all three of these. And we're having people do all three of these. In fact, the bottom two of these that I said, the fast ones are so good, not very many people are even doing the smart contract version. In fact, Hero, TuneFM, yes, they're jam tokens. They've even moved it to being at the token service rather than the smart contracts because it's so much faster. So we have all three ways of doing tokens. I think it's easy to overstate things, to say everything in the universe will be tokenized. That's not quite true. But what is true is that ledgers and tokenization is going to seep into every part of the world economy, every sector, every corner of it, and every part of, I think, society in general. It's not just the normal economy. And I think we are going to see that. I could talk about why I believe it. It doesn't mean that tokens do everything. No one tool does everything. But this is a tool that's going to seep into our life in every part, in our economies in every part. Tokenization is a big deal. And you mentioned identity. I haven't even talked about identity, but we have people doing that as well. I think identity is also going to be a big deal. 2021 maybe is the year where tokens are truly changing the world. I hope that identity is going to be not too far behind. There's lots of identity projects right now, and I'm hoping that they will have some of the stature that NFTs have right now in the near future. This is exciting times.
So I want to touch one thing in terms of the ecosystems you're building. So you mentioned the corporate ecosystem and this case study. So let's say one of the things that made, of course, Ethereum the biggest platform for blockchain worldwide is the community of developers around the platform. And even the Cardano, even if Cardano, it's a bit more tricky because there's not really a lot of case studies. There's most like scientific academic papers. And in your case, you have already the velocity of processment of payments and other things. So in terms of developers listening to us or organizations, can you tell us how you've been building the community? You mentioned UCL. I've been actually working with UCL as well. But what other communities are building around your platform? And these cases are more driven by corporations, or you have a mix of corporations and as well community of developers?
Yes, it's a mix. So we have corporations that I've talked about. We also have community, individual people. Some of the applications I'm talking about are started by individual people. Some are started by big corporations. You have startups that are kind of in between. We have thousands of developers. We have developer evangelists that go out to those. We have things like, well, here's one. When you have individual developers, what they often will do is start building tools like the SDKs to let you use the system. So we have 3 SDKs that we've built. You can write your code in Java or JavaScript or Go and use one of the SDKs that we've written, the software developer kits, to make it easy for you to write your program. Or you can use one of multiple SDKs in multiple other languages that have just been developed by the community. Rust and lots of other languages. They just said, we want an SDK in that. And the community on its own did it. And now the community is building apps using the SDKs that were built by the community. It's community to community. In the very early days, features were things that we made up and we implemented. But nowadays, we have the HIP process, the Hedera improvement process. These are like the internet RFPs, or this is, anyway, these are ways that the community can propose changes. And we have those now that the community has proposed things, the community talked about it. There might have been a few people that were employees of big corporations, but basically these were just all individual people, just people that were into the ledger space. And they made good suggestions, then they debated it, and then the HIPs were actually approved. There's several HIPs that have been approved. I even was involved in one of them, HIP 15 I was involved in, which was checksums, kind of fun. But the community had lots of things to say about it, and it changed and it evolved as the community did it. It's approved, it's now an official HIP. And so community is building things like wallets, there's a whole bunch of them, custody services, all sorts of infrastructure things. And the community now will start using this standard that the community helped evolve and approve. The community now, when it builds things like wallets, will show you your account with a checksum, 5 letters after it, just so if you ever type it in wrong, it'll catch the typo for you. That was a HIP process. The community is involved in that, and now the community is the ones who will be using it. So that's the kind of way that we get the community involved. We also have had a bunch of hackathons, which have been just amazing. You would not believe some of the things that were done in the hackathons. And many of them have gone on then to become startups. And so this was a community of just a bunch of individuals that wanted to do some programming in a hackathon and then banded together and formed a startup. And we have funded some of them with the prize money. There was incubators. Helix was an incubator that incubated a bunch of these. And then others have found funding from other places. And so the community is turning into corporations because they're startups, which is kind of fun to see too. And I love that. I just love the community involvement. We have ambassadors. Ambassadors are just people in the community that just think this is interesting and have been very involved. And they've done startups, and they've done communication, and they're doing coding efforts and all sorts of things. And we have our ambassadors, our most important people, or VIPs, just MVPs, most valuable players, just all sorts of people are involved from the community, grassroots. And it's been very exciting. And this actually started, kind of a long answer, but it just started even back in 2018, when we were just starting to talk about these things. And even in late 2017, we were seeing this huge interest from the community in Hashgraph, even before there was a Hedera, just in Hashgraph as a concept, and lots of excitement from the community. And that's just been building over the years.
No, it's really impressive. And I, as I mentioned, I've been following you guys for a long time. So one of the things that is really kind of an hidden secret, although it's not a secret, is that your currency, because you are one of the top currencies in the world with a market cap, as we speak, of at least the 1.6, $1.8 billion, and the fully diluted market cap with around $10 billion, 9.907, something like that. So can you tell us a bit about, because of course, normally people talk about, like when you talk about the top 10, top 20 cryptocurrencies, Hedera Hashgraph doesn't appear so much as a lot of others. Although you have a volume of $500 million per day, which is quite impressive. Could you tell us a bit about, first of all, I know that it empowers the platform, the currency, but I would like to talk and compare your currency, of course, the value with a lot of other, well, not in the corporation, but what is unique about your currency, but as well, a bit of the work you've been doing around that, because of course, there's a massive community. We're talking about one of the biggest in the planet.
Sure. So what is important, you brought up price, I'll talk about price, but what is important is not price. The important thing is we're building a project that will last for 100 years. We're building a 100-year company. We're trying to build something real, and we're getting huge traction. But it is nice to see the price went up tenfold in the last few months. But that's not important. What's important is not that we went up tenfold. It's also fun to look at it compared to the market, or compared to Bitcoin. If Bitcoin's a proxy for the whole market, it's gone up a lot. It's been a beautiful, in fact, I think we reached an all-time high just a few days ago compared to Bitcoin. So none of that is important. What is important is that the entire project has been well designed. And part of being well designed means we designed the cryptocurrency part of it well. So what is the cryptocurrency? It's the Hbar. It is a fixed supply. It is not inflationary nor deflationary for that matter. For greater predictability, you want a fixed supply. There is a fixed supply of Hbars. The way it is used is you have to use it as the fuel on the network. Every time you do a transaction, you pay for it in Hbars. I told you it was 1/100th of a cent, a 10,000th of a US dollar. And that is how we peg it. We keep it at that value. But of course, you can't pay dollars yet. CBDCs are an interesting concept. But right now, what you have to pay for is Hbars to do anything. Actually, even with CBDCs, I imagine you'd still be paying in Hbars, but there'd be conversions between them. But you'll be paying in Hbars. The amount of Hbars you have to pay goes up and down as the price of Hbar goes up and down. So you have predictability in your pricing, but you pay in Hbars. Hbars are the only way to use the network. We have to have a cryptocurrency for that. In addition, it's a proof of stake network. And the idea is to have the Hbars be the stake, and therefore it's part of the security of the system. And we're being very cautious in how we're rolling it out, but we're starting off with permission and going to non-permissioned and so on. But in the end state, all of the security comes from the Hbars. And so we have to make sure that's secure. And we're doing that. Hbars are also what is currently managed, a lot of them, you talked about some of them aren't circulating yet, they're being managed by the council to make sure that nothing bad happens, like they all get dumped on the market at once or something. The council manages the Hbars. And the council has multiple committees, and it is the council members that vote on these things, and they ensure that we're doing the right things with them. So that's what I can say about Hbars. They're on lots of exchanges, I don't know, 40 exchanges or something. If you go to Hedera Hashgraph, if you go to hedera.com/guide, it has a list of all the different exchanges and all the different wallets and all the different custody services and all that stuff. So
all these links during the interview, and it's really, of course, it's one of the major ones. So one of the things that actually brought us to this interview, and then coming back to NFTs, I didn't mention that when I asked, but I want to touch that. It was that you recently have been trying to create a demonstration of operation of a sustainable marketplace for NFTs. And you've been hosting an auction on 2 physical Hbar coins, representing, I'll read the press release because I think it's interesting for this, represented by NFTs on the Hedera network, which will proceed going to the women homeless shelter in Dallas. I think you should do this in a bigger scale. I love Dallas, but I think your token is much bigger. So your PR firm should work with you because I'm a huge fan of you guys, and I think you should go bigger. But it's really interesting. I would like to touch the sustainable part of this, because it's a big thing. And of course, recently, of course, actually one of our members of board, Professor Yu Xiang, did a big paper, a scientific paper. I don't know if you heard. It actually was one of the biggest papers picked in the Nature magazine about the electricity consumption of Bitcoin. I think it's one of the most scientific papers projected in the last couple of years because, of course, of Bitcoin volatility. And actually, partly from what I understood, the reason that, well, there's different reasons, but one of the reasons Elon Musk plug out of Bitcoin was partly because of that paper. It's a paper by 10 scientific teachers from different universities worldwide. So I would like to touch, first of all, if you could highlight what you're doing in this project, the auction of physical Hbar coins for the women homeless shelter in Dallas, point 1. And then part 2 of the question about the sustainable marketplace for non-fungible tokens, because it's something that I'm very interested in. And I know that Hedera, it's different because Hedera doesn't really have so much issues like Bitcoin and even Ethereum. And I would like to touch these 2 questions. So 2 questions. First of all, just tell us about this initiative, and second, about the sustainability part of the marketplace.
Sure. So this auction is fun. We're about to do an auction. And in 2018, I made some metal coins that have an Hbar logo on them. It's actually kind of cool. It's a solid coin, pretty thick. And then the Hbar logo is actually a hole through the coin. You can see through it. It's kind of neat looking. And so I made 2 of them. One was gold colored and one was silver colored. They're both from Shapeways, and I think we're going to sell these in our store that were printed at Shapeways, 3D printing company in metal. It's very cool. So anyway, we had these 2 coins, but I've had them since then. I then this year stamped into those 2 original coins serial numbers, number 1 and number 2. And I am committing to never again stamp serial numbers into any of these Hbar coins. These are the only 2 that will ever exist. and I made a certificate saying that I made it and that it's the only ones that will have serial numbers ever, and that these are the serial numbers. And the certificate I took a picture of, and so we have a file that has the picture of it. So we have these three things. You have the physical coin, you have a piece of paper that says this is authentic, and then you have a picture of that piece of paper. And what we are doing is creating a non-fungible token from each of the coins. There'll be two non-fungible tokens. The non-fungible token has the hash of the file, which is the picture of that paper. And so it will show ownership of the coin and the paper, the authenticity certificate. And the tokens are then going to be auctioned. So we will have an auction. The winner of the auction gets the token, and the non-fungible token, the NFT, and gets the metal coin and the piece of paper. All the proceeds from I just donated this to Hedera. So I just gave away my coins and the paper and the stuff to Hedera. Hedera is going to create the NFT out of it. Hedera will do the auction, and then all the proceeds of the auction will go to a homeless shelter for homeless mothers in Dallas. And so that's where the money is going. This is just one auction. There'll be other auctions. The money will go to different charities, but we're just sort of starting here. And part of what we're doing is just doing this. It's fun. Part of it is to show that you can do auctions. And you talked about sustainability. Every bid in the auction and every the final transfer of the token to the winner are these transactions that are 1/100 of a cent. And the reason they're 1/100 of a cent is because we do them for so little energy. We can do 10,000 a second. Each one is very, very tiny energy. And so this auction is an example of how you can do sustainable commerce with NFTs. Auction is one kind of commerce, and this is just showing how you can do it. All the code we're writing to do the auction, we're releasing open source. Anybody can read it, anybody can use it, anybody can use it to do their own auctions, or you can modify it and do different kinds of auctions. I think that auctions with NFTs are a big thing. NFTs have been sold for many millions of dollars through traditional auction houses. You can also sell them through your own auctions. You don't have to go through traditional auction houses now. The barrier to entry is very low. Even if there are 10,000 bids on this coin in the entire auction, then the entire auction's overhead will be $1. You know, it's going to be a very cheap auction. And you could set up a service to do auctions. You could have people listing their own things, you know, like eBay, that kind of thing. People could set up companies to do that, or set up startups to do that, because it's so easy to do. NFTs allow this. Physical objects have lots of problems. NFTs don't. Physical objects, you have the problem, what if I pay for it and I don't actually receive it in the mail? And then what if someone claims they didn't receive it, but they really did? And how do you adjudicate that dispute? NFTs don't have any of that problem. It can just be mathematically guaranteed. You're going to get your cryptocurrency if I get my token. And if you don't get your cryptocurrency, I don't get my token. If I don't get my token, you don't get your cryptocurrency. It's an atomic operation. And we can do this in the world of NFTs. You can't do that in the world of physical objects. And so it's very exciting that we can now, the world has the ability to do auctions that are so fast, so cheap, so sustainable, and there's no way there can be disputes. You can make it so that it's guaranteed to be trusted without having paying $1 million to an auction house to do it for you. So that's the first half of your question. I'm excited about this auction. I think this auction is going to be a lot of fun. I'm just looking forward to what happens with it, and we'll see.
Just one question: where can people buy the NFTs? It's just through your e-commerce platform, or are you going to do it in other platforms?
Sorry, I wasn't clear. We have a store for physical objects where you can buy hats and T-shirts.
So it's in the store. That's my question.
The metal coin is in the store. Yes.
Okay.
So those aren't NFTs.
Yes, I understand. Yeah.
I understand. Okay. So yes, people can go to the store. We have a store, and you can Google it and find it. But you can go to the store and you can buy hats and T-shirts and little metal coins that are really cool, gold and silver colored. And not gold, they're gold colored, but they're cool looking. Or if you want one with a certificate of authenticity that's been here since 2018, it's the first 2 coins I ever created. I've stamped personally, I'm with my hands stamped in serial numbers into them, which turns out to be really hard to do. It turns out that nickel is a very hard metal. I didn't think of it as hard, but it's really hard to stamp in a serial number. But I did it first serial numbers I've ever stamped in my life, you can then go to the auction. And the auction will be in a month or so, and you'll be able to buy that. Roll into it at once right now.
And it will be, the auction will be on the shop.hedera.com?
No, it's hedera.auction.
Okay, Hedera.auction. Okay, no, because I found, I wanted, for people listening to us, because of course, there's some people that are traders, and of course, I know that you guys are one of them. So I'm just curious, even me, because I'm starting some of my collections, so I'm curious. Okay, very good. So I want to touch, and I know that I'm cautious of your time. One thing on this part, I want to touch, if you would mind. I think you probably were touching it, but I would like so. In terms of part of what you're doing is the Hedera Consensus Service, the HCS, will be leveraged to facilitate the creation of a secure public token sale application with an unmatched degree of sustainability. So this is part, can you describe this? And for instance, on the sustainability, which I'm particularly interested, the difference between, for instance, your NFTs or something in OpenSea or in Nifty Gateway and different areas.
Yeah, so sustainability is important. Everybody is talking about this now. And we've been sustainable since the beginning because of the low power. So there have been reports, Power Transition did a report I saw that was 5 million, said we use 1/5 millionth as much energy per transaction. The amount of energy per transaction is incredibly low. And actually, as we increase our number of transactions per second, it'll go down even further. Right now, we've throttled it down to 10,000, but as it goes up higher, it'll be even lower. So it's incredibly low requirements of electricity in order to produce these. And someone could say, well, it'd be good to power things with solar panels, and we're looking into that sort of thing. But the best way is to just megawatts, not spend the electricity in the first place. Rather than building more solar panels to create more electricity you're going to waste, the better solution is even just to not waste. And then for what little you need, we want that to be sustainable. And we can talk about that too. But the goal is to use as little energy as you can. Be efficient, first of all. And then with your efficiency, be green. But the first step is to be efficient. So we're very efficient there. In addition, though, to the ledger itself being sustainable and green, there are people building on top of us for things like enabling energy markets. You have people who have solar panels on their house, or they have a windmill and they want to sell power back to the grid, and then other people on the grid are getting it, and you can have a market for the electricity. And by doing that, you're encouraging the sustainable things, the renewable resources like the solar panels and the windmills and things. And so we have people building on us to do that, to be doing markets of electricity for that. In addition, you mentioned NFTs and sustainability. Not only are we a sustainable ledger for sending around NFTs, we have people building on us to use NFTs directly for this purpose. There are carbon credit NFTs being built on top of us, carbon credit trading systems being built on top of us, so that if you have carbon credits to sell and someone else wants to buy carbon credits, you can lower the friction of it, make it easy to buy and sell, encourage people to be buying carbon credits, and that's being built on Hedera. And so Hedera is at multiple levels of the stack. Hedera itself is doing its best to be using as little electricity as possible, but then we have people on top of us doing things like electricity markets, which encourages renewable resources, and carbon credit markets, which encourages renewable resources. And then there is even the combination of the two, which is really cool because it shows something about the way the world economy is going in creating new kinds of markets that couldn't exist before. Imagine buying a kilowatt hour in real time and buying the carbon credit that goes with it in real time, and having them combined, and in real time having a market that is buying both the credits and the electricity at the same time, so they cancel out. And so we have a system being built on us that does that. There's a bunch of companies building on top of us to do these things. And so I think for sustainability, NFTs are good. And if you're going to do NFTs at all, you should do them on a ledger that is sustainable. And so we're interested in the whole spectrum there.
I think it's an area that I'm particularly interested as well, as someone actually we're building, as I mentioned to you, an NFT platform as well on the top of our platform, citiesabc. But one of the things I've been kind of finding, and I want to touch that as probably, I have two last questions. I want to be cautious of your time. So one of the things that is very complicated right now, for instance, I am, of course, a power user, and I've been in blockchain since the beginning and writing about this in the books and things like that. But if you are an artist or even if you are in collector and you want to buy an NFT, at the moment it's very complex to go to even OpenSea. If you don't have a wallet, if you don't have capacity to understand how it works, a wallet and putting everything working, it's going to be difficult to do it. So I would like to touch one thing. So as someone that is working with these big corporations that own the Hedera Hashgraph, in terms of the work you're doing, in terms of transforming and democratizing a lot of these solutions, can you tell us a bit some of the work you guys have been doing, especially when it comes to, let's say, the payments area, which is a big thing still, because let's be honest, I think the biggest democratization of crypto in general has been Coinbase and PayPal, and they're now Square as well. So, but I'm not talking this just purely from a trading or speculative part, but as well from taking this to the masses and making solutions that can work. And I know that you've been working, especially when it comes to tokenization. You mentioned for instance, fashion industry, a lot of all these things are really very, very important. But I would like to touch this because, of course, you are a bit more advanced. You have a very big bridge with big corporations. First, you mentioned Google. You mentioned some of the top corporations in the world. Is there any kind of case study in terms? Because one of the things I'm always focused on, actually, since my first ICOs that I created and have been involved, one of the things that was always very focused is using the technology for good, but as well using the technology for the day-to-day. So if you could actually go a bit on some last example that you want to highlight on the things where I know that already transactions, you're already far ahead of the competition, but on this part of more, I would be interested to hear a bit about you.
Oh, this is so important. As a market, the entire ledger world is really bad when it comes to usability. This is something that we have to fix, and this is something we think is incredibly important. So right now, there are a lot of exchanges, and there are a lot of wallets, and we're integrated with a lot of them, with both our Hbars and with the tokens. So if you do a token, you can integrate it easily into all of these ledgers, these exchanges and these wallets. And anybody who wants to can get a token, and they can get a cryptocurrency using these exchanges and using these wallets. And it is not an easy, painless, trivial experience. There's a very good chance your grandmother might have some problems with being able to get tokens and get cryptocurrency. Okay, this is what you have in an embryonic field. You have the early adopters who are willing to go through the pain, and that's where we are right now. That's wonderful, but we've got to get rid of the pain. It has to be easy to use. And so we're starting to see some of the big payment companies starting to say, hey, we're actually going to incorporate tokens. Banks in the US are now allowed to be custodians of tokens. We're starting to move towards where the industry is growing up and where it would actually be easy to do, where it will be easy to trade cryptocurrencies and tokens and other things. We have a council member, EFTPOS, EFTPOS. They are a household name in Australia. A dominant payment system in Australia. And when you go to the grocery store, you just pay with EFTPOS. Everybody does that. They're now a council member, and they are doing tokenization. They are doing tokens, on us. And they are trying to make things easy to use. And we have a number of other initiatives I'm aware of where people are trying to build things like wallets and so on, and they're trying to make it where the average person can use it. And typically, this isn't just having an app on your phone that's a little bit easier to use. Some of the apps aren't so bad, but it's also integrating into the apps you're already using and into the banking system that you're already using and the credit card system you're already using, the payment system you're already using. This is how it's going to start becoming part of everyday life. Hedera is very much tied into a lot of these initiatives. And the market, our market right now, the world of ledgers is bad, but that's to be expected in the early days. But we've got to get to the next stage and stop being bad. And I'm excited that I really do think we are on the verge of this. And rulings like saying banks can be involved is a huge step forward in that. I love that US ruling, and we have a lot of banks in our council. We've got to make things easy to use, and easy to use in many cases means invisible. There have to be lots of applications where you don't even know you're using tokens. All you know is you're playing a game and you've got some assets in the game, and maybe I gave my credit card. You don't even know there were tokens involved. That's the way we're going. Oh, we're doing work with gaming companies too. That's what we're involved in, is making it invisible, so easy that in many cases you don't even know you're doing it. That's where we're going.
For me, that is the most important thing, because I'm all as someone that has been as well an academic and writer, I think my main concern is making sure that we have enough speculation in the world. We need to create value. And I know that you guys have been focused on that from the beginning. So I think probably the last thing is, can you tell us more just a bit of an overview for people where they can find Hedera, of course, besides the website, and a bit more of some of the things that you have going that you want just to publicize here. Besides the event, we're going to put the notes to the auction and to the different things, but other things that you have ongoing that you want to promote as a last highlight.
Sure. So you talked about the auction, you talked about lots of exchanges are using us and wallets and so on. You can get it there. You can go to the website to get through us. We have the talk tomorrow at Consensus. I'm looking forward to that with Spencer Dinwiddie. That's exciting. His Galaxy thing is exciting. The auction is exciting. We'll have other auctions beyond those 2 coins. Those are exciting. I would say that the biggest thing I would encourage is the community to get involved in the HIP process, to get involved in the HUG process. I forgot to mention the HUG. The Hedera user group is a way for big companies, but also lots of the community, individual people, to get involved with Hedera and to give input to Hedera and to give input to each other and network with each other and talk about how things can be used and for Hedera to help them. Get involved. Get involved in the Hedera user group process, the HUG process, get involved in the HIP process, the Hedera improvement process. If you want to write some code, do that. Get involved in our hackathons that we keep having. I'm just so excited with the community. Come to our town halls. We have a town hall every month. Come to those. Just excited with the way we've had so much support from the community, and I would encourage that as well.
Fantastic. Well, it's been an honor, Leemon. I think I'm a fan of your work, and I hope that you can continue growing and scaling the public ledgers and all the solutions about this, and especially that we can actually have more solutions, because I'm all driven by solutions. And I might get a follow-up because I'm particularly interested on the areas of identity and other things. Thank you so much for your time. It's been an honor, and we'll promote all of this, of course, within our platform and the interview and podcast series. Thank you.
Thank you very much. I loved being here. Thank you for having me. Thanks.